Hello Year 1005 mathematicians, Mr. Herman here, and this video will be looking at Lesson 3, Exercise 4C, Elevation and Depression. The learning goals for this video is to know how angles of elevation and depression are measured, and to also know how to apply the correct trigonometric relationship to solve a problem. The success criteria is to be able to draw and label an appropriate diagram from a word problem description and identify a right angle triangle, and to also be able to apply the correct trigonometric relationship to solve that problem. So we are now looking into context of elevation and depression. There are two new terms that we use in regards to real-life context of trigonometric functions, because it's one thing to know the skills of SOHCAHTOA and applying the right function to solve for a side or solve for an angle, which we did in 4a and 4b respectively. But now we're going to look into using the words angle of elevation and depression to solve real-life context. So the angle of elevation is measured up from the horizontal. So think of the horizontal. Horizontal just means a line that goes across from left to right. Horizontal, the opposite of horizontal is a vertical, which goes up, down. Okay, so angle of elevation, which we can see here, here's a horizontal. And then when we draw a line from the horizontal and we measure up, this is called the angle of elevation. And then the opposite of this, the angle of depression, is measured down from the horizontal. So this horizontal, you can draw as many horizontal lines as you wish until we get to maybe the top of a building or the top of some context. This technically still is a horizontal. When we measure down from this horizontal, we have the angle of depression. So technically speaking, I can draw a line that goes from here to here, like so, and this angle here can also be considered the angle of depression. It just really depends on what context the question is talking about, whether it's talking from the ground or the top of a certain thing, maybe a building or height of something flying, and we'll see this in a few examples. For now, in order to be able to solve more complex problems involving trigonometric functions or trigonometry, we need to visualize and draw a right angle triangle. No matter what type of question we get, we always draw a right angle triangle, so a triangle that has 90 degrees, and add any information that has been provided or given to us. We're going to fill in the gaps. Then we're going to use a trigonometric ratio, either sine, cos, or tan, to find the unknown. There will always be an unknown. This unknown can either be a side length or it can be an angle. Side length we know how to solve for by using sine, cos, and tan. An angle we know how to solve for by using the inverse function of sine, cos, and tan, which we can find on the calculator. And then you answer the question in worded format, because if the question is provided in worded format, you always answer it in worded format. Now I'm going to be looking at two different examples. One of these examples, I've got a diagram which I've taken straight from the textbook, and the other diagram is not going to be provided. I'm actually going to draw it. Now you can look at the textbook example. They've got a diagram readily available, but I want to show you how to actually draw this diagram and given the information, because this will be considered the trickiest part, and you can always have room for error if your diagram is incorrect. For now, let's just look at this example 5. A helicopter is hovering at an altitude of 250 meters. The angle of elevation from the helipad to the helicopter is 35 degrees. Find the horizontal distance of the helicopter from the helipad to the nearest centimeter. Okay, There's some information that we have to dissect here. The first thing we know is that the helicopter is hovering at an altitude of 250 meters, meaning it's just flying in the air here by a distance of 250 meters. So we know it's 250 meters high. The angle of elevation. So we know that we're talking about an angle that starts down and it goes up like this. The angle of elevation from the helipad. So helipad is the pad that is actually on the floor, so it's on the ground. So the angle of elevation from the helipad or from the ground to the helicopter is 35 degrees. So this right here is the helipad. When we create this angle of elevation, so the angle that goes up to where the helicopter is, so it's to the helicopter, we're creating an angle of 35 degrees. And then what we're trying to find is the horizontal. So remember the thing that goes across, either left to right or right to left. We're going to find the horizontal distance of the helicopter from the helipad. So of the helicopter from the helipad. So we're looking for a distance that goes across like this. In this case, we're looking for this here. This is a question like this is X meters. We don't know what this is. And we're going to find this to the nearest centimeter, provided that the information is given in meters. So let's redraw this triangle and let's fill out what we do know. There is a 90-degree angle here. The helicopter is here. It looks something like that. We know that this length here is 250 meters. We know this degree in here is 35 degrees, and this is what we're looking for. Now, using the skills from the previous exercise, we are going to label this triangle. We're going to label what we do know. So we're provided with an angle. We're looking at a side that is opposite the angle, so O for opposite, and a side that is next to or adjacent to the angle, which is A. The hypotenuse, or H, is not being provided or is not an interest that we're looking for. We're not looking for this length. So we need to see which trigonometric function uses the letters O and A. And in this case, it's tan, because that's O and A. So we're using the tan of the angle, which we know is 35, is equal to the opposite over the adjacent. So the O, 250, over our adjacent, which is X. This is a line we don't know. In the exercise 4a, we know that if there is a letter that is on the bottom of the fraction and we need to solve for this, all we do is swap it with a trigonometric function. So in this case here, our X is going to be equal to 250 divided by tan 35 degrees. And this is where we use our calculator to solve for that trigonometric function. So we're going to put fraction in using the fraction button, 250 on the top, and on the bottom we're going to put tan 35 degrees, closing the bracket. And we end up getting 357.04 because the number afterwards is a 7, meaning this rounds up by 1 unit. So 357.04, 357.04 meters. And remember, we've got to answer this in worded format. So we would say therefore, so remember, therefore just means from the calculations that we obtained previously, therefore, where the horizontal distance of the helicopter from the helipad helipad is 357.04 meters. And that is all there is to it. So what we did, just to break this down, we had a diagram readily provided to us. We put in the information that we do know. We labeled what the sides were based on what angle was provided to us. We figured out which trigonometric function we had to use. And because x was on the bottom this time, we just swapped them around and then used the calculator to provide that answer. Then when we got that answer, we wrote this down in worded format. And the next and last example, we'll be looking at a bit more of a complex example because there's quite a bit of information to dissect. Even though it is a shorter question in comparison, no diagram has been provided. We have to create our own diagram. So you're going to see Mr. Herman's sketching abilities at his finest. Let's have a look. The two vertical buildings, 57 meters apart, are 158 meters and 237 meters. We are going to find the angle of elevation from the top of the shorter building to the top of the taller building, correct to 2 decimal places. Okay, quite a bit of information to dissect. You'll notice that there is this SOHCAHTOA. I always write this out of habit so I know which trigonometric function I'm going to use, sine, cos, and tan, and I know whatever sides are provided, I'll use that trigonometric function. In this case here, we are looking for an angle. Okay, we're looking for an angle, so we know for a fact we have to use inverse function of sine, cos, or tan. But for now, let's draw two vertical buildings. So we have building 1 and we also have building 2. Now we know for a fact that one of the buildings is shorter than the other. The first fact says that two vertical buildings are 57 meters apart. So this distance here is 57 meters. This horizontal that's on the ground here is 57 meters. Now mind you that this is 57 meters anywhere within the height of the buildings until the tallest part here. So we know here this distance is also going to be 57 meters. It has to be because it runs consistently along, and we're assuming that these two vertical buildings are parallel with each other, unless one's leaning, but it doesn't imply that within the question. So one of the buildings is 158 meters tall and the other one is 237. So out of the highest one, this here is 237 meters because it is the tallest building. It's the tallest out of the two, meaning this building here has to be the shortest out of the two, which is 158 meters. So now I'm just going to get a different color here, so I can color the building so you can differentiate the differences between the two buildings. So we've got a blue building. Yeah, we've got a blue building, and let's change it to maybe weird looking limeish green. Okay, we've got a second building. There we go. So we've got two buildings. So the first one is a tall one. We know this to be 237 meters, and the second one is the shortest one, and we know this to be 158 meters. All right, so this part here gave us so information. This was just one sentence. What we need to find now is the angle of elevation, so the angle that goes up from down to top. So we're looking for an angle that looks like this, and it goes this way. We're finding the angle elevation from the top of the shorter building. So the top of the shorter building is here. So we're finding the angle of elevation from here to the top of the taller building. So the top of the taller building here, let's just create this line that goes from the top of the shortest to the top of the tallest. It's that line there. And we're finding the angle of elevation. So we're finding this angle here. All right. We know that there is a 90 degree here, which runs horizontal here, this 57, and vertical here. This meets at a intersection, and we call this perpendicular. It's perpendicular because it runs straight across at a 90 degree angle. So we can redraw this triangle. Okay, we can extract just this information and put it here to create this triangle here. But we run into a little bit of a hiccup, and it's not too tricky to solve. In fact, it's probably the easiest part to solve. But right now we are looking for this angle here, this theta. We don't know what this angle is, so I'm going to leave it as theta. We also know that this length on the bottom here is 57 meters, as this is that width that runs across. Now the information about the hypotenuse, this length here, hasn't been provided, and yet this length here also has not been provided as well. And this is what we need to solve for, because we can't solve for this. There's nothing to indicate what this length is. We don't know what the hypotenuse is, but we can solve for this vertical height here based on the fact that this tall building is 237 meters and this short building is 158 meters. So to get that length there, we just need to find the difference between these two lengths here. So in other words, if we get 237 and subtract 158, so we get 237 and subtract 158, we end up getting 79, meaning that this distance here is 79. This length here is 79, because this length is also the same as here. That's also 79, and 79 plus 158 gives me 237. So this length here is 79 meters, and voila, we have at least two lengths, and we're going to try to find this angle. So now let's label this. We have been provided the opposite side of that angle, so over opposite, and adjacent. So again, we're using tan. So SOHCAHTOA, O and A, we're using tan. But this time we're solving for an angle. So the tan of this angle, which we don't know, is the opposite, 79, over the adjacent, 57. And now we're going to use the inverse function. We're trying to look for the angle, so we know that the angle is equal to tan inverse. And remember, inverse is just indicated by a little -1, which is just above the trigonometric words tan. So on your calculator, clear this. Remember to press Shift and then tan to get the tan inverse, so the little -1 on the top. Get your fraction button, put 79 on the top, 57 on the bottom. Make sure you move across to close that bracket and go equals. And here we have 54.19, because the next number afterwards is higher than 5, so this rounds up by 1. 54.19. 54.19 degrees. And this is degree. Remember, we're looking for an angle. We're looking for an angle. A lot of people get into autopilot mode and put 54.19 meters. No, that's an angle. We're looking for an angle, so we have to answer it in degrees. But more importantly, we have to answer in worded format as well, because it's a worded question. So I'm just going to write it out. Therefore, what was it that we're looking for? We are looking for the angle of elevation. The angle of elevation, the angle of elevation we don't need to write the full context from the top of the shortest building to the top of the tallest building. We can just say the angle of the elevation obtained or provided or created is 54.19 degrees. And that's all there is to it. This part here, creating this diagram, is probably going to be the trickiest part out of everything, especially if you're not up to scratch with some of the context that provided, especially the tricky words. You know, not many people, it seems a bit weird, but not many people knew what a helipad was. They thought a helipad was like a station that floated up in the air, but no, a helipad is a pad that a helicopter lands on the floor. It seems kind of obvious, but you'd be surprised the amount of students who kind of don't know the context of everything within the outside world, and kind of don't know how to apply a diagram based on the information given. So you can use Google to help you out, or you can always ask me. In the meantime, you'll be looking at elevation and depression, which is exercise 4C, page 282. These are the required questions you need to do based on foundation, standard, and advanced. See how you go, guys, and I'll catch you in the next video. Bye-bye.